Hi all, today we are going to discuss about effect of earth on capacitance of the transmission line. So this is generally solved using the method of images. So method of images are used for solving these type of problems easily. So before going to this, let us see the background that is required. So here I am writing on a glass screen, so handwriting doesn't come properly. So I am providing the complete handwritten material in the description of this video. You can please download the material from there. Here you try to understand the concepts what I am teaching here. Remaining material you can please refer from there. So we have seen till now that if I am taking a charge of plus Q, the flux lines will radiate out from this radially outwards like this. And if you calculate the electric field at a particular point, that means it only depends on the radius, or we have seen there that the equipotential surfaces will be formed like this, or at any particular point the electric field lines that pass are always the radially outward direction. This is the case for the isolated charge. Isolated charge. So this is what we have seen already. So let us now see the case of, if let us take for example I am taking a metal. So I am taking a metal. So whenever any metal is kept in the vicinity of the electric field, we have also seen that electrical boundary conditions. So we have seen in lecture number 37 of EMFT. So there we have seen that whenever the electric field is passing like this, always the electric field enters and leaves at normal to the surface of the conductor or normal to the surface of this metal, and inside the metal the electric field intensity will be equal to 0. This is also we have seen in lecture number 37. We call it as the equipotential surface, and always the flux lines will be normal to this, and inside flux lines will be equal to 0. So same thing will be the case of the earth, because whatever the flux lines are coming out from the conductor, when the flux lines enters the earth, because earth can be taken as a very good conductor or it can be taken as equipotential surface where the flux lines will enter normal to the surface of the earth. Or otherwise we can tell that if you are taking some conductor, if you are providing the earth, it is observed that whatever the flux lines that radiate out from this conductor, they radiate out from the conductor in such a way that when they pass here, they have to pass only normal to the surface of the earth. So whichever the direction they are coming, they will pass only in normal to the surface of the earth. This is what is obtained. Let us take for example, this is charge Q. So this can be visualized in a different way. Let us assume I am taking one charge plus Q, and it is also observed if you keep the charge minus Q, the flux lines will come out like this and end at the second one. So they will end at like this. And if you calculate the potential, so generally in between these two conductors, that means between these two charges, here the potential will be equal to 0, or the potential is equal to 0, or the neutral plane will be in between them. And the second one, on the neutral plane, it is observed practically that the flux lines are coming normal to that point. Or we can tell that the effect of earth can be analyzed like this: wherever is the potential neutral plane is there, that plane can be assumed as the earth. So how this is coming? By taking one charge on the top and taking another equal and opposite charge on the bottom side, having the same distance from the ground. Let us take for example, this is having a distance of h. So at a distance of h from this, we can take a negative charge and then draw the flux lines, and in the center we can take it as the earth. That can be implied for representing the effect of the earth. So the method that is used, so this is called as the method of images. The method of images. So method of images is useful how the flux lines originated from a particular charge will terminate on the earth, or how it is going to affect the capacitance of it. Let us take for example, I am taking this as the earth, or this I am taking as zero potential plane. So which I am taking as ground, because our ground is there. So from this the flux lines will radiate every side. So the flux lines will radiate like this, but whichever flux lines comes here, so they will come in the, they will enter the earth in the normal direction only to the earth. So like this they will enter, all will enter in the normal direction. Getting it? So what we do, we take the height h. So we assume that there is one more charge here, so that the analysis will be easy, which is having the same charge. If plus Q is there here, minus Q will be there here. So this is called as the image charge. Image charge. Just by checking the image charge, if you are calculating, then in that way we can easily calculate the effect of earth on the capacitance. So in order to further analyze this, let us take the single phase capacitor line or single phase transmission line. So I am calculating the capacitance of single phase line by considering the effect of earth. So for that, let us assume the transmission line is having two conductors. One conductor is A, another conductor is B. Let us assume it is carrying a charge of plus Q, because this will be written conductor, it will be minus Q, and the distance of separation between them I am taking as D. This is my real charge. Let us assume this is my earth. So the earth is here. So what we can do, as per the method of images, I can assume that there is opposite charge that is lying below. So I am taking two charges here. So these two charges, because this charge will be opposite to this one, and I can take this as A dash. This charge will be opposite to the charge that is above, this is minus Q. Similarly, this will be B dash conductor, because charge is minus Q above, here it will be plus Q. These are the image charges. That means these are image charge. So again the height also we will assume that the height is equal to same. Here height is equal to h. So as per method of images, we have to take this height as h, or this I can calculate. This will be equal to square root of 4h square plus d square. This is the distance from conductor A dash to B or conductor B dash to A. So let us try to calculate the voltage. So VAB will be equal to 1 by 2 pi epsilon naught into, how to calculate this? Take any charge. So QA I have taken, ln of what is the distance of this charge with respect to the point B, because I want to calculate from A to B. So distance of that point with respect to B will be equal to DAB, and distance of that point with respect to conductor A. So this we will take as the radius R only. So actually this is DAB minus R, because DAB is very large, so compared to the radius, so I am approximating it as DAB. Please consider this one. It is not going to affect your result. Same thing is the case QB into, what is the distance of conductor B with respect to B? It is radius R. Distance of conductor B with respect to A, that is dBA. So similar is the case QA dash ln of distance of A dash conductor with respect to B. This will be dA dash B divided by distance of A dash conductor with respect to A. Similarly, QB dash into ln of what is the distance of B dash with respect to B divided by distance of B dash with respect to A. This is what we have to substitute. So I am just substituting that, I am calculating here. VAB will be equal to 1 by 2 pi epsilon naught into Q into ln of D by R plus the second charge is minus Q. So this will be ln of R divided by D plus the image charge, because A dash is equal to minus Q. This will be ln of square root of 4h square plus D square divided by 2h, the distance I have written here, then plus Q into ln of 2h divided by square root of 4h square plus D square. This is what we get. So this I can further simplify. This will become equal to 1 by 2 pi epsilon naught into 2q ln of D by R into 2h divided by square root of 4h square plus D square. So wherever q is there, here and here, I have combined them together. Okay, this is the one, and similar is the case. This is minus q. Minus q means this minus I can take inside, so this will become D divided by R. They will interchange. Same thing is minus, if you take inside, this will interchange. So this will become plus q into this one. So that's why R by D also, D by R is repeating 2 times, and 2h by square root of 4h square minus D square repeating 2 times. So that's why I have written 2q. I think it is clear up to now. So this I can write as q by pi epsilon naught into ln of D divided by R into square root of 1 plus D by 2h whole square. I can further simplify it like this. So this is my value of VAB. So from this I can calculate my capacitance CAB. So CAB will be equal to pi epsilon naught by ln of D divided by R into square root of 1 plus D square by 4h square. This one is the value. So this will be in farads per meter. This will be, remember, line to line value, because we are calculating between A and B. If you want to calculate capacitance between the phase and the neutral point, so which I am representing by Cn, Cn will be, because this is just equivalent to two capacitors connected in series. One capacitor between the conductor and the earth, another capacitance between the earth and your negative conductor. So total two capacitors are there. So it will become, if you want to calculate to the neutral, so this will become 2 pi epsilon naught into ln of D divided by R into square root of 1 plus D square by h square. Okay, this is what is there. This is in farads per meter. This is to neutral. So let me try to draw this. It is like this. So this is Cn and this is Cn. So total value will be equal to CAB. So if you are taking Cn as same, so CAB is equal to Cn divided by 2, or otherwise we can tell Cn is equal to 2 times of CAB. That's why I have multiplied with 2. Please don't confuse here. So now this is my final equation. The effect of earth is considered here. So you can see here, in the normal case we have derived it as a d by r, but here one extra term is coming, square root of 1 plus d square by h square. So this is what is the extra term that is coming, r is multiplied with this term. So practically what happens, the value of the height is far greater than the distance of separation between the conductors. So in that case I can take 1 plus d square by h square. This I can approximate as 1 because the value of h is far greater than d. So automatically this Cn will become equal to 2 pi epsilon naught divided by ln of d by r farads per meter. So that's why the height of the tower is more, then you can neglect it. But if the height of the tower is less, then you have to consider this parameter also. You have to multiply, r will be modified to r multiplied by square root of 1 plus d square by h square. Getting it? So now let us take the capacitance of 3-phase line. Capacitance of 3-phase line. So let us just use the GMR and GMD concept. So let us assume that the conductors are equally spaced. So A, B, and let us take it as C. You can randomly take any conductors. So let us assume the earth is here. So image conductors I have to assume below. So I am taking the image conductors. Image conductor will be C dash, B dash, and A dash. Let us assume this height is equal to H. Okay, getting it? So now how to calculate this one? Let us try to calculate VAB. VAB will be equal to 1 by 2 pi epsilon naught into QA into ln of. So you have to take the distance between DAB, because I have to point from B to A. So this will be DAB by R. Similar is the case QB ln of, because B to B distance will be R and B to A distance will be equal to DAB. Plus similar is the case QC ln of, the distance between B to C. Distance between B to C is DBC. Distance between B to C to A, this will be DCA or DAC. Plus similar is the case for image conductors, QA dash into ln of DBA dash to DAA dash. Similar is the case QB dash into ln of DBB dash divided by DAB dash, plus QC dash into ln of DBC dash by DAC dash. So this is what is there. So once this is there, I can simplify this one. So this I am simplifying here. This will become 1 by 2 pi epsilon naught into QA into ln of. So I am combining the QA term, similarly QB term and QC term, because this QA dash is nothing but equal to minus QA. That minus I can take inside. When I take inside, this denominator come to numerator, numerator come to denominator. So that's why I am writing here. So this can be written as DAB multiplied by DAA dash divided by, the denominator is all multiplied by DBA dash. Similar is the case QB into ln of R divided by DAB is already there for first one. Now this QB dash term, denominator numerator just exchange and multiply here. This will become DAB dash divided by DCB dash, plus similar is the case for QC into ln of R multiplied by DAC dash divided by DAC into DCC dash. So this is what we obtain. So this is what we obtain. So now I am further simplifying this one. So this is the value we got. Let us take it as equation number 1. So similarly, I can calculate the value of VAC also. So VAC will be equal to 1 by 2 pi epsilon naught into QA into ln of DAC DAA dash divided by R into DC. So I am writing it DCA dash plus QB multiplied by DCB into DAB dash divided by DAB into DCB dash plus QC into ln of, so ln I am forgetting, right, ln of R into DAC dash divided by, so this will be equal to DAC into DCC dash. Okay, I think the first one I have written something wrong. So this will be equal to QB into R into AB dash. So this one I am just changing, I have written it wrong. So this will be equal to DBC dash into DAC dash divided by DAC into DBC dash. DBC dash. So please don't confuse here. So please change it, because I am following the steps, I have written it by mistake. I have exchanged these two. So this will be, I am taking as the equation number 2. So from this I can take the sum of VAB plus VAC. We know this sum is equal to 3 times of VAN. So the reason I have explained in the last class, because we are taking this as VAN, this is VBN, and this is the value of VCN. So I told you the sum, this will be equal to VAB and this will be equal to VAC, and the sum of these two, this will be equal to VAB plus VAC. So this will be equal to, if you calculate, you will get it as 3 times of VAN. Please check it once, because we have already discussed in previous class. So I am skipping for now. So let us take for example, this distances I am taking as DAB is equal to DBC is equal to DCA is equal to D. They are equally spaced. And similarly DCC dash is equal to DBB dash is equal to 2H, and DCB dash is equal to DBC dash is equal to some G, which will be equal to square root of D square plus 4H square. Getting it? Similar is the case DAA dash, I am taking it as F, and DAC dash is equal to DAB dash is equal to length L. So now from this I can calculate my value of VAN is equal to 1 by 6 pi epsilon naught. I have to take the sum of those two equations and then substitute these things. So when I am substituting those things, so you will get it as, I am directly writing the answer, ln of d square f square divided by r square l square plus qb into ln of r into l square d divided by 2d square h into g plus qc into ln of r d l square divided by 2d square h into g. This is what we get. So we know the value of qb plus qc. This will be equal to minus qa, because qa plus qb plus qc is equal to 0. You can see here this one is same as this one. So we can add them qb plus qc. So I am further simplifying this. This will be equal to 1 by 6 pi epsilon naught into qa into ln of. So if you simplify this, it will become d square f square 2d square hg divided by r square l square r square l square. This is what we get. So this I can write as qa by 2 pi epsilon naught into ln of d by r multiplied by 2f square gh by l to the power of 4, this whole to the power of 1 by 3. This is what we get. Or from this I can calculate my value of CAN will be equal to 2 pi epsilon naught divided by ln of d by r into 2f square gh divided by l to the power of 4 whole to the power of 1 by 3. This will be in farads per meter per phase value. So here what are the values of these terms? F will be equal to DAA dash, L will be equal to DAC dash is equal to DAB dash, and similar is the case G will be equal to square root of D square plus 4H square. So this way we have to substitute and calculate it. Here also you can see the effect of earth. So extra one more term is adding. So this is the term that is adding to this. So because of this automatically the value of capacitance is changed. That's why we can tell that the effect of earth of the capacitance is there in the case of 3-phase line also. And if the values of this H is so much dominating when compared to other terms, then remaining all can be assumed as they are nearly equal to H, because F, G, L all can be taken as equal to H. So all will cancel out. This term will be equal to only D by R. I hope how to calculate the effect of earth on the capacitance, what is the method of images is completely clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you. Thank you very much. Hi all. Today we are going to discuss the electrostatic effect of radio interference. Let us take for example, I am taking 3 power carrying conductors which is A, B and C, which are kept in the equilateral triangle, and let us assume a transmission line or a communication line is passing nearby, which is represented by the conductors D and E. So what is the effect of the electrostatic effect of these conductors A, B, C on these communication lines can be analyzed easily by taking the method of images. In the method of images, whatever is the value on the top, so same image, we assume one more image is existing below which is having the opposite polarity of the charge what is passing on the top. That means DE I can represent by D dash E dash with respect to the ground having the same distance. Similarly, the A will also have its image, the C also will have its image, B also will have its image below the ground. So this is represented by B dash, C dash and A dash. So the distance will be same. So this also distance will be same with respect to the A dash. HA will be equal to HA dash, or both are same. So now using the method of images, let us try to solve. So in this, I am assuming the each of the conductor is having a charge of Q coulombs per meter length on the conductor A, then the potential that is induced in conductor G due to the potential at conductor A, so that I can represent as VAD is equal to minus Q divided by 2 pi epsilon naught into integration from, we have to do the integration from HA to DAD. DAD will be, because we are taking from infinite or to the ground to the point we are considering, or we are taking up to D. So that's why DAD is the distance between conductor A and the conductor D. That will be 1 by x. This is due to conductor A, and it is having an image conductor also, image conductor A dash. So if you calculate for a given value of the x, this can be represented as 1 by 2 times of HA minus x. So that is the distance of the image conductor A dash with respect to the location where we are considering, that x you are considering. So this will be dx. So this will be equal to Q by 2 pi epsilon naught into ln of 2 times of HA minus DAD divided by DAD. So let us take it as equation number 1. So let us take the voltage at conductor A between A and the image conductor A dash. This can be written as integration from 2 times of HA minus R, because we know the electric field inside the conductor is, because it is a equipotential surface. So inside the electric field will be equal to 0. Electric field will be only starting from the surface of the conductor, or it starts from the radius R of the conductor, and second conductor, the distance between these two is 2 times of HA. So we have to subtract minus R, and similarly it is up to surface of the first conductor R. So that's why I am representing this. This will be EX dx. This we have already seen in electromagnetics. If you still have doubt about this, you can please refer to my electromagnetics lectures. There I have taught this in complete detail. So, and moreover, one more thing, I am providing the complete handwritten material in the description of this video. You can download the complete handwritten material from there. Here you just try to understand the concept I am teaching, and you can download the complete material for the exams from there. So this will be integration from, because when compared to 2 times of HA, the R is far less. So this R can be neglected when compared to this. So this becomes 2 times of HA to R, Q divided by 2 pi epsilon naught into, so because of one conductor it will be 1 by x plus 1 by 2 times of HA minus x. This is due to the second conductor or the image conductor. This value we get, so this will be equal to Q by 2 pi epsilon naught into 2 times of ln of 2 times of HA minus R divided by R. Because we know VA dash is voltage of A with respect to A dash, or this I can write as voltage of A with respect to the ground plus voltage of ground with respect to A dash, or otherwise this I can write as 2 times of voltage of A with respect to ground, or 2 times of voltage of A, because VA represents that is with voltage with respect to ground. So that's why this I can write as 2 times of VA. Done. So now from this I can calculate my value of the VA, 2 will cancel, we can calculate it, or from this I can derive the value of the Q will be equal to VA into 2 pi epsilon naught divided by ln of 2 times of HA minus R divided by R. Let us take it as equation number 2. So now this equation number 2, the value of the charge I am substituting in equation number 1. This equation number 1, wherever Q by 2 pi epsilon naught is there, I can represent this one, Q by 2 pi epsilon naught, the epsilon naught I can take here. This will be VA by ln of 2 times of HA minus RA. So when I am substituting this, you will get this value as VAD is equal to VA divided by ln of 2 times of HA minus R divided by R. This will be multiplied by ln of 2 times of HA minus DAD divided by DAD. So let us take it as equation number 3. So this is potential difference between conductor A and the conductor D, or the potential of conductor D due to the effect of the conductor A. So similar way I can calculate due to the effect of B and C. So total potential in the conductor D will be equal to the effect of each of these values. So this will become VAD plus VBD plus VCD. So because of this the voltages are induced in the respect to communication lines in each conductor. So similar way I can calculate for the case of conductor E also in the similar procedure. So now how to decrease this value, because always this value will be non-zero. So how to decrease this value, what are the remedial measures to make this electrostatic effect as 0? So that can be done by transposition of the power lines neutralizes the unbalance in the capacitances of lines, because all this effect is coming due to capacitance effect. If the capacitances are equal, we know that the respective charges passing through each phase are displaced by 120 degrees. So because of that they will nullify out if you are transposing the transmission lines, so that the electrically induced voltages are balanced out in complete set of transposition. So transposition, two things will be there, one is the charge and the second one we can tell that it depends on the distance of separation between each conductor to the communication line. So I want each conductor to the communication line distance should be same, but it is not same. So by doing the transposition that distance becomes same, so automatically it can capacitance will be get equalized in all the lines. Then the transposition can equalize the magnetic fluxes due to positive and negative sequence currents. This is for the case of magnetostatic effect we have discussed in last class. So positive one negative sequence currents, but zero sequence current cannot be nullified, because zero sequence currents will be in phase with each other as they are in the same phase with each other. So the induced voltages due to zero sequence current can be eliminated by transposition of conductors of the communication line. So whatever the zero sequence currents are coming, you just transpose your communication line by transposing, because in a loop they will get cancelled out. Even though the voltages are nullified between the two conductors of the communication line, still the voltage between the conductors and ground is not nullified. So the insulator should be of proper rating to withstand this voltage. So in order to give the proper justification of this statement, let us take one example so that it will be completely clear to you. So after the example we will discuss in detail. So I am taking a 3-phase 11 kV 50 Hz feeder, has horizontal configuration with 1.2 meters between adjacent conductors. The height of the conductors above the ground is 10 meters. A telephone line is run on the same supports. The horizontal distance between the telephone wires is 0.6 meters. The vertical distance between the power line and telephone line is 1 meter. So first part they have asked, find the magnitude of voltage induced in the telephone circuit due to electromagnetic induction if the power line carries a balanced current of 300 amperes. Then if the power lines has a diameter of 14.15 mm each, calculate the potential of the conductor P above the earth due to electrostatic effect. So how the electrostatic effect is creating the voltage, why insulation is required, that also it is asked. So whatever is given in the numerical I have just represented in the form. So here you can see the three conductors are kept horizontally. They are displaced by 1.2 meters apart. And this is my transmission line. Transmission line is kept a distance of 0.6 meters among them. And the height of each conductor with respect to ground is 10 meters. And the height or the gap between the power conductors and the communication conductors is given as 1 meter, that is a vertical distance. So I have based on this I can calculate the distance between each conductors. So I can write the distance between D, A and P, that means conductor A and P. Similarly it will be equal to conductor C and Q because of symmetry. This will be, if you calculate it using the triangle method, you will get it as 1.345 meters. So similar way DBP and DBQ, with respect to B, both P and Q are symmetric. So if you calculate the distance, this will come as 1.044 meters. So similar is the case, DAQ are equal to DCP, that will be equal to 1.803 meters. And it is given the current is balanced. So I am taking the current as balanced. IA is 300 at an angle of 0 degrees. IB is 300 at an angle of minus 120 degrees. And IC is equal to 300 at an angle of minus 240 degrees, or I can write it as 300 at an angle of plus 120 degrees, because both are one and the same. So let us try to calculate the flux linkages. So I can calculate the flux linkages which we have seen in the last class. So the flux linkages can be written as 2 into 10 to the power of minus 7 into the value of IA is 300 at an angle of 0 degrees into ln of, we have to take the distance of conductor A with respect to the second conductor Q. So with respect to Q it will be DAQ is 1.803 divided by DAP will be 1.345 plus the second one is 300 at an angle of minus 120 degrees, and this distance will be B with respect to Q and B with respect to P, both are 1.044. So, this will become ln of 1.044 divided by 1.044. So, this is the value. So, now coming to the third one. So, third one will be 300 at an angle of minus 240 degrees or plus 120 degrees into ln of C, making a distance with respect to Q. C with respect to Q is 1.345 and C with respect to P is 1.803. Okay, this will be in Weber turns per meter. Using this I can calculate flux linkages. So, this will be equal to 304.5 into 10 to the power of minus 7 at an angle of minus 30 degrees. This is what we obtain. So, now the voltage induced in the telephone line. The voltage induced in the telephone line will be 2 pi f into lambda. So, this will be equal to 2 pi into your supply frequency is 50 into this value of this flux linkages we got as 304.5 into 10 to the power of minus 7. So, this will become equal to 9.57 into 10 to the power of minus 3 volts per meter. So, you can see here per unit length you are getting as 9.57 into 10 to the power of minus 3 volts per meter. So, like this the voltage will be induced in the overall transmission line. So, because of this voltage divided by impedance of your communication line. This is my communication line. So, in this the voltage induced is 9.57 into 10 to the power of minus 3 volts per meter. Like this, depending on the length of your wire, the voltage will be induced. This multiplied by length of your line gives what is the total voltage that is induced due to electromagnetic effect or due to magnetic effect. So, because of this voltage divided by impedance of your line or your loop, so this gives a current. So, one current will pass because of this interference. So, this current will add to the current that is because what is passing in the communication channel. So, your signal get distorted due to the effect of this electromagnetic effect. So, let us see the second case, the electrostatic effect. So, it is given the radius, the diameter is given, the diameter is equal to 14.15 mm. So, radius will be 14.15 divided by 2. So, this will become equal to 7.075 into 10 to the power of minus 3 meters, because I am representing all in terms of meters. So, I can calculate my VA is equal to, it is given as 11 kV, this becomes 11 kV by root 3 at an angle of 0 degrees, and the value of VB is equal to 11 kV by root 3 at an angle of minus 120 degrees, and the value of VC is equal to 11 kV divided by root 3 at an angle of minus 240 or plus 120 degrees. So, now the potential of the conductor P due to the conductor A. So, this I can calculate as VPA will be equal to VA into ln of 2 times of HA minus DAP divided by DAP. This will be divided by ln of 2 times of HA minus R divided by R. This is what we get. So, this will be equal to 11,000 divided by root 3. This is having an angle of 0 degrees. This will be multiplied by ln of 2 into HA is equal to 10 minus DAP is 1.345 divided by 1.345 divided by ln of 2 times of 10 minus R. R should be represented in meters, 7.075 into 10 to the power of minus 3 divided by 7.075 into 10 to the power of minus 3. So, if you calculate this, you will get it as 2100 at an angle of 0 degrees. So, similarly, I can calculate my value of VPB. VPB will be equal to VB, whatever is the value of VB, into ln of 2 times of HA minus DBP divided by DBP divided by ln of 2 times of HA minus R divided by R. This is the value. So, if I are substituting the values, you will get this value as 2317 at an angle of minus 120 degrees. Similar is the case, you can calculate for the VPC. Similar type of formula will come. If you calculate it, you will get it as 1847 at an angle of plus 120 degrees. So, this is what we get. So, we can calculate the total potential on conductor P will be equal to, total potential of conductor P will be VPA due to A and VP due to B and potential of P due to C. This will be equal to, if you take the summation of this, vector sum of this, you will get it as 407 volts. with the angles. So you can see here the voltage is not nullified. What does this indicate? There is a communication line. It is telling that this communication line B, this is communication line Q. So with respect to this ground, this potential is coming as 407 volts. This potential is coming as 407 volts. Similarly, you can calculate for Q. So it will give some voltage. Let us assume VQ, some VQ is coming. So the potential difference between these two will be VP minus VQ. There is no issue. But you can see each conductor is raised the voltage above the ground level. Let us assume if a person comes here and touch this conductor. If they touch the conductor P, what will happen? He will experience the shock because this voltage is very high. So we have to take care of this voltage. So here the first thing is, because it is above the ground level, whichever things are carrying this, that should be able to withstand this much voltage. Otherwise the dielectric breakdown will happen there. So proper insulation is provided for this in order to protect this voltage. Along with that, you have to try to nullify this or make some measures so that it will be nullified in the end. Take some measures so that it will be nullified in the end. So these different methods, how we can nullify this, those I have already discussed in the above before discussing this numerical. I hope the complete analysis of electromagnetic and electrostatic effect on the communication lines is completely clear to you. If you still have any queries, you can leave your comments in the comment section below. I will answer to your queries from there. Thank you very much.